This is Daniel once again, and today we are going to look at how to find the limits of a function. We're going to look at the indeterminate form. So we are considering the shortcuts. Now we know that for a function f of x, when we are taking the limit as x approaches a certain value a, we substitute the value into the function. So for instance, for a function x minus 1 over x plus 3, to take the limit of this function, we substitute 0 into the function. We have the limit as 0 minus 1 over 0 plus 3, and that gives you minus 1 over 3. Now, what is the indeterminate form? So, assuming that you substitute the value of x into the function and it gives you 0 on 0. So this form is what we term as the indeterminate form. So never in your life say if you have this form, indeterminate form, say the limit of the function is 0. That is wrong. So for a function in its indeterminate form, what you got to do is to break down the function so that you can substitute the values, which takes a couple of time. So in this video, we're going to use a simple principle to find the limits of a function that ends in the indeterminate form. The principle is known as the L'Hopital's rule. Now, what does this rule say? If you have a function that ends in the indeterminate form, what you got to do is to differentiate. So you're going to differentiate each term in the function. For instance, three s squared minus 5s plus 2 on s squared minus 1, taking the limit as s approaches 1. Now, taking the limits, we're going to substitute 1 into the function, and that gives you 3 minus 5 plus 2 over 1 minus 1, and that is 0 on 0. So this is an indeterminate form. So what you got to do is to take the differentiation of each of the terms. So we take the differentiation of this, we have 6x minus 5 over x squared, which is 2x. So we are going to take limit as s approaches 1. So in this case, we substitute 1 into the function, 6 minus 5 over 2, and that is 1 over 2. Let's look at another example. Limit as x approaches 9. The function is 9 minus x on 3 minus root x. So you know that substituting 9 into the function gives indeterminate. So what you got to do right now is to differentiate the terms one by one. So we differentiate 9, we have 0. This will give us minus 1 on this is 0 minus differentiation of a root x is 1 over 2 root x. So you know when you simplify that, this is going to give you 2 root x. Therefore, limit as x approaches 9 of the function 2 root x is equal to 2 root 9, and that should give you 6. The last example we're going to look at, limit as x approaches 3 of the function 9 minus x squared over 4 minus root of x squared plus 7. Alright, so the same thing, if we substitute, we have indeterminate form. So what we have to do is to differentiate the term by term. So you differentiate s minus s squared, you have minus 2x over, this should give you 0, minus, differentiate what is in the radical, 2x over 2 root of what is under the radical, s squared plus 7. Right, so this cancels that. This simplifies to 2 root s squared plus 7. Now taking the limit, we have limit as x approaches 3 of the function 2x squared plus 7. We substitute the values into it. We have 2 root of 9 plus 7, which is 2 root 16, and that gives us 8. Anytime you have indeterminate form, instead of breaking the function into its simplest form, the simplest way is to differentiate it term by term, and you substitute the value of x. If after substituting the value of x you still obtain an indeterminate form, still differentiate further. This is the simplest way to find the limits of a function in the indeterminate form. You can try your hands on this function. So till I see you in the next video, I say stay blessed.